All right, good morning, everybody, and welcome to another Office Hours. I got a crew with me again today. As always, it's VCloud Matt Vanbild. I got Z House, Michael Kolos with us, and we're joined today. Oh, Aiden's in here as well. Let me promote him to a panelist. We'll kick him out and come back in. We're also joined today by some of our esteemed brethren in our new organization from our VCPP team, Harold Simon and Martin Hoskin. I don't know if either one of you guys wanted to say hi and introduce yourselves. The rest of us have kind of introduced ourselves several times, but go ahead if you want to.
Yeah.
Martin?
Hi, Matt. Yeah, excuse the background noise, but yeah, I'm Martin Hoskin. I'm a principal architect in the cloud practice, which is a pre-sales organization um, within VMware. So I'm more focused on pre-sales, but as we come together with post-sales and professional services, customer success, etc., this is now all moving into a single organization, as you guys know. So hopefully you'll be seeing a bit more of us.
That was good. Harold, did you want to give a little brief introduction?
Hi, yeah, this is Harold Simon, and excuse me for the background noise as well. I'm a staff cloud solutions architect with the global cloud practice, and I focus with partners and customers that are using VMware Cloud on AWS.
Excellent. Me and Harold go way back in the VCDX days. I think it's been 6 years since I got my first VCDX. That's incredible when you think about it. But anyway, so today we don't have too much on the formal agenda. I'm just going through, our team was just given access to Wavefront. So I am kind of playing around with that now, getting that all set up into to our environment, and it requires a proxy VM, so that's kind of what I'm doing right now. Like I said, the floor is open to anybody if they have anything that they want to discuss or bring up, or if anybody out there in Twitch or in Zoom wants to ask a question as well, definitely go for it. Um, Mr. Dalglish, I saw you sneak in. How are you doing over there?
Yeah, not too bad. Thank you. Been working on a few customer challenges this afternoon, so keeping me on my toes.
Well, what are you talking about? None of our customers have challenges, right?
Absolutely.
As with any new product, we're a lot of times we are learning as we go, and the constant product is constantly evolving as well, which is always making us learn more and more and more. I've been in a lot of meetings discussing a lot of the features of M7 coming up here well, not shortly, I guess a couple months still for M7, which will be around VMworld timeframe. We were just discussing before everybody else joined. We're looking at putting together some VMworld submissions, so I didn't know if we wanted to talk about some of those now. I have put one in, so if anybody wants to go out there and vote, I think I put in something around VMware Cloud for the front lines, which kind of talks a little bit about what Aiden and I were just talking about with working with our customers and running across some new things and some fun stuff and figuring out the best way of doing everything. We have a lot of experience now in doing that across our customer base, so there's definitely some knowledge there that we can impart to the community, and we'd like to do it. That's why we do this, and all those kinds of fun stuff. We were talking, I saw a little bit in the Slack chat earlier about some of the routing calculations and stuff, and that's definitely not my strong point. So, still working on the networking side of things. I know NSX fairly well, but after it gets into the actual physical network, I get a little out of my element. That's where Michael and Z come in for me.
No, part of the fun is that we're one of the earlier adopters in VMC of NSXT. So I know a lot of people out there have been running NSXV with their vSphere environments for some time. It's a pretty popular solution, but a lot fewer are running NSXT. It's a relatively new offering, and VMC is the adopter of that. So we're getting to get some firsthand experience trying that out and taking advantage of some of the things that it does in VMC. I mean, from the user point of view, it doesn't really make things terribly different. You still manage everything through vCenter and through the VMC console, so you get kind of the same access. It changed the graphics a little bit, but in terms of capabilities in VMC, it certainly has really upped our game.
Yeah,
Primarily,
I think that's a really good point, actually, Michael. That when we went to NSXT, I think it probably doubled or tripled our install production base of NSXT when we went to VMC. So definitely some learnings there. Now, but yeah, I mean, this is the portal with which you manage it through. It's not, very complex. It's there's a lot of options and a lot of things in here, but it's a pretty straightforward interface, and it's constantly evolving. We're constantly adding more and more new stuff. Like as of the M7 release, we added the troubleshooter and some more of the statuses around our VPNs. We don't actually have one set up in this environment. I guess I could look at C's if we wanted to dig a little bit more into here. And again, excuse the funds. We pay our bills. We swear.
Mine might be down, but I can resolve that real quick if it is.
Yeah, you could still show the some of the interesting things that came out in the last release are if you expand the caret on the left side there, Matt. Just expand the caret next to it. Yeah, there you go. Yeah. So we've added a few things on the right-hand side, like view routes and download routes. If you click on view routes, this is something that our customers were asking for. They want to know what we're learning because it's great. It's all dynamic. It takes care of things for you. But if things don't work the way you want, or you're not clear on what's going on, before it was a little difficult to tell. So now we've exposed this information right here in the UI, so you can see exactly what routes are being learned and sent out to the environment. So that's a new feature, and like Matt said, there's the BGP status you can see, and the tunnel status. Yeah, maybe this is a good point to talk about VPN, some of the configuration options in VPN, because I've actually just been working with our docs team to get a lot more of this detail updated in our docs, because the VPNs are some people are a little confused by VPN. There's a lot of different options, as you see here. A lot of different terms that go with VPN. We've got the route-based, the policy-based. We've got encryption, ciphers, IKE, phase 1, phase 2. Like, there's a lot of different terms, and maybe it'd be helpful to go through some of those and sort of talk about what they mean and why you want to use them, what they're there for, what they do. So if we don't get any questions, I can do a little bit of background on IPsec VPNs.
Sure. Did you want to drive to maybe go through some stuff, or?
Well, I'll just talk through and
sure.
Let you be the Vanna White of the VPN clicking for now.
Well, hey.
Gotta give you credit where it's due, right?
Yeah.
So we'll start with the basically what route-based and policy-based VPNs have in common, and that part is the actual tunnel. So both use IPsec. The IPsec relies on IKE to set up the tunnel, which is sometimes referred to as ISA camp, depending on if you're using Cisco. But essentially, it's Internet Key Exchange. That's how the tunnel gets set up and negotiates the encryption properties, and then that performs that's IKE is your phase 1, we call it in some terms. So if you see phase 1, it's referring to the IKE tunnel. That's sort of the outer layer of the IPN tunnel. It's that sort of if you think of it as the pipe analogy, that's sort of defining your actual pipe. And then within that, you set up security associations, or SAs, and that's your phase 2. And those they define the sort of different types of flows that are going through your pipe, and that's where you start to see a bit of a difference between route-based and policy-based. Although they still work, they both set up SAs. What happens is a route-based VPN will set up a single security association that covers all your traffic. So it uses the pipe as a single entity just creates a pipe through it and lets the routing determine what goes through that. So it sets up a tunnel with, or a security association, I should say, with the entire internet route on both sides. So it'll route 0/0, quad 0 through both directions. Sets up everything can go through. And then you create a point-to-point tunnel interface and run BGP over that. So usually we do that with the 169, 254, the APIPA range, because it's only talking to the two endpoints. That's all. So /30 is enough. And then they negotiate BGP, and you create a BGP session that determines your routes and what actual real subnets you want on each side, and set up the routing. So that's what a route-based VPN does. There are some implementations that allow you to use static routes to do that rather than BGP. In VMC, we only support using BGP to do that. So BGP is pretty flexible. It's relatively easy to set up. All you need is basically an autonomous system number, or ASN, on each side, and each end needs to know its own ASN, its own interface for the tunnel interface that I mentioned before, the APIPA or 169.254 network. And then it also has to know the remote side. So because BGP is a point-to-point protocol in terms of communication, as opposed to something like OSPF that does broadcasts, BGP actually has to know what the remote side is. You have to tell it. And then once you do that, assuming that your settings are in alignment on both sides, everything else will just negotiate. And in VMC, we make it pretty simple. There are a lot of parameters you can control around the routing in BGP, but in VMC, we basically just, everything is predefined. So we advertise out all the routes that are in your SDDC, and we'll learn whatever you send to us. And if you need to do any more advanced filtering of routes, or adjusting different metrics or costs, or AS path prepending, for example, some of the common BGP attribute manipulation to control the routing. You can do that on your on-prem side, not on the VMC side, just to keep it simple here. But anyways, I didn't want to get into BGP session because we're still talking about our IPsec VPN. So let's go back to the tunnel itself and phase one. And this is where essentially policy-based and route-based are the same. And you'll see here we've got what's called advanced tunnel parameters and IKE encryption. Your IKE, as I mentioned, is phase one. So that's the first setup. And for that, we've got an encryption, which is a cipher. And here we've got AES 256 selected. And if you can just go to edit, Matt, maybe we'll show what the options available are for these different ciphers. So IKE, we've got two different levels of AES encryption, 128 or 256. And then we've got these GCM options, which also have different depth of bit encryption. GCM is actually I won't pronounce it because it's people's names. As much of the encryption naming is after the inventors of those encryptions, but it's a completely different type of process. Even though it's still AES, it's actually not at all the same. And so when you choose these GCM, which is actually I'm wrong. It's not even after some of these names. I think I'm forgetting, but it's based on a counter modulus, all mathematical techniques that allow you to go one way very easily, but reversing that calculation is extraordinarily difficult, and that's why we use those for encryption. So it's a much better performing cipher than the regular AES. And it actually doesn't even need a digest type. So one thing is, if you choose the one of those AES GCM types, there are a couple of things you need to be aware of on the IKE side. So for one, you need to be able to use IKE v2 to support that. IKE v1 doesn't support the GCM ciphers. And then in addition, you're going to want to choose a digest algorithm of none. So Matt, you want to show? So the digest algorithms, you have SHA1 or SHA2. SHA2 is also known as SHA256. But those will apply to your regular AES. If you use a GCM, the digest is actually part of the cipher itself. It actually does checking. So the purpose of a digest is to validate that the data was not modified in transit. So there's always those 3 pillars of security: confidentiality, integrity, and availability. So the digest is part of your integrity portion. You might have confidentiality that somebody else can't read it, but you don't want them to inject malicious data into your packets, even if they can't read it. So that's what the digest is for. And GCM includes that as part of the cipher. It does checksuming, and therefore you don't need that. So if you ever choose a GCM-based protocol, you want to choose the digest algorithm as none. And this applies to both the tunnel and the IKE encryption side. So you can set them separately with our NSXT now. It used to be that they were grouped together. However, typically you're going to want to keep them the same. If you use one for the IKE, you probably want to use the other one for the tunnel or phase 2 or SA encryption, just to keep things simple. There's no hard requirement for that. Sometimes makes things easier to support across your different products. Now, another thing to note, so there are some limitations in support around the IKE protocol. So you'll find that not all devices will support using the GCM ciphers in the IKE or even IKE v2. So if you are connecting to, for example, AWS VGW, they don't support using the GCM ciphers on the IKE tunnel. So you'll have to set it to the good old AES. You could still use, they do support GCM, I believe, on the tunnel encryption, the phase 2, just not on the IKE. And like I said, the advantage of it is that it basically gives you better performance for the CPU utilization. So you can get higher throughput. So that kind of covers your encryption cipher and digest options. Diffie-Hellman is another one that we'll see. And the purpose of Diffie-Hellman is it's basically another key selection mechanism. And the group number is basically how many times it iterates through the algorithm. So obviously, the more times you iterate, the harder it is to guess the key that you're using. The purpose of it is just, again, to make sure that your security is it's harder to guess your keys, to prevent certain types of attacks. We recommend a minimum of group 14. Obviously, the higher you use is the better option, but we do support all the way down to group 2, which is for compatibility with older devices. So, like I said, group 14 is our recommended minimum. If we go on to the other side, we have perfect forward secrecy. That's another one that comes up. Sounds great, perfect forward secrecy. What's its purpose? The purpose of PFS, or perfect forward security or secrecy, is to prevent your keys. Basically, what it is you don't use the same key for encrypting as you used that you negotiate. So the purpose of this is that if somebody ever compromises your key in the future, they can't record all your sessions, expect that they'll compromise your key in a year, and then go back, take your recorded, all the data that they captured from your VPN session, and then now decrypt them because they've got your key. So the idea is it uses a different key for the actual data encryption, so that even if somebody compromises your private key that was used for that VPN, they can't actually go back and replay that for your data and unencrypt the data. It's sort of a real-time thing, and that's why it's called perfect forward secrecy, because they can't capture the data, take it forward, and then decrypt it later on. And so we always will recommend that you can use that if it'll work between your endpoint devices. These days, most endpoint devices will be able to support that. Sometimes there's some incompatibility because of the extra key selection, but in general, that should be a pretty simple option. It's either on or off. Pre-shared key is just the authentication mechanism. So there are 2 authentication mechanisms that are used by an IPsec VPN when you go to connect. So obviously, somebody's going to connect. One side's going to reach out to another side. Somebody has to trust that they're the right side. How do we know who you are? And so that's where authentication comes in. So we support pre-shared key as one method. Some devices will use certificate-based. Currently, we don't support that. So you're going to have to put in a clear text, well, it's not clear text, but essentially it's a clear text key. You can hide it from the UI. But this is just a string that should be relatively complex and long that you're going to share some other way, some other secure way, so that both sides have something in common. The other piece of the authentication is basically the IP address, and it's used through the ID. So it's not actually used through the IP address. It's used through the what's called the ID parameter. So each VPN will have a local ID that they'll use, and it has to match what you're expecting. The default is generally to use the IP address, the public IP, and that's why it's essentially IP, but it doesn't have to be that IP. And the reason for that is sometimes you have your VPN behind a NAT. So your VPN endpoint or gateway doesn't actually know what its public IP address is. So it has to have a way. And this is why we provide a field up there where we say remote private IP just below the pre-shared key. What that actually means is that if your remote gateway is behind NAT and it doesn't know what its public IP is, it's going to use a private IP for its identifier. If we're using the public IP and it's using the private IP, what's going to happen is we're going to get an authentication failure. And sometimes that message can be confusing because you'll look at your VPN won't come up. You'll look at the error message and it will tell you authentication mismatch, something like that. And you're saying, well, the only authentication I have is my pre-shared key, and I've copied and pasted that like 40 times. I know it's right. You know, it's ABC 1, 2, 3 on both sides. I can't be wrong, but I'm still getting this. That's why, is because what it means is your ID is not matching. So you have to make sure that you have a matching local ID on your VPN gateway on-prem to whatever you've got in this remote private IP box. So if you don't populate that box, it's an optional box. What we'll do is we'll use the remote public IP. So where you see gateway IP address, the option, which is the public IP we're going to contact, we'll use that IP address by default. And in fact, you'll even see it if you save it and you go back and edit it. Sometimes you'll see it in the UI. It'll automatically populate that. But if you don't use that, if you're using a different IP for a local ID, you need to put that in the remote private IP, and that forms the second part of your authentication. So if you ever get authentication errors when you're trying to set up your VPN tunnel, those are the two parameters you need to look at: is the key and the private IP. The other parameter you see here is BGP secret, and that's really nothing to do with the IPsec VPN. That's to do with the route-based BGP config. We've kind of got three different sets of configs mixed together in this UI. We've got the IKE phase 1, we've got the SA phase 2, and we've got the BGP. They're all three separate protocols operating at three separate layers, and they're all put together in the same config. So it's important to understand which one goes with which. And in this case, this is labeled as advanced BGP parameters. If your BGP negotiation is using a secret key or same thing, it's just a matching key. No fancy encryption going on here. It's just a shared secret. And really the goal is just to prevent somebody else from negotiating BGP. In an IPsec VPN, it's often not necessary depending on your configuration because you've already authenticated the tunnel. As long as there's no way for anybody else to get into that BGP connection because the interface is only available over this VPN, you may not need this. But if there's any way that the interface IP that you're using for BGP is accessible to any other connection, it's often a good idea to do this just so that you don't have a BGP session hijack. And if anybody, of course, is able to forge the IP or hijack your BGP session, they can then inject any routes and hijack your traffic that way. So that's the purpose of that BGP secret parameter. Couple of other points while we're on the routed VPN and the BGP. So we'll see we've got a couple of IP address options here at the top row. These are sort of the basic settings. So the local IP, it's a drop down, and we give you two choices. There's public IP or private IP. Public IP is what most people would use. It's the internet IP address. That's when you're doing a regular internet-based VPN, you'll use that, and that will go out over the internet connection in your VMCS DDC. So there's a native internet connection built in through AWS's connectivity. There's an ITW in there. And that traffic will always go out that IGW, no matter what you've configured, what routing you've configured. If you have a direct connect, that if you select public IP here, it's always going to go directly out that internet connection. We automatically route that in. So that's one thing to consider if you use the public IP. If you want to use the private IP, that's a new option that we've added in with the NSXT option in one of the recent updates as well. That allows you to run VPN over your direct connect. So if you have a direct connect private VIF, it's generally considered a private network connection, but some organizations require encrypting traffic on top of that. They don't trust the carriers to provide all their security, so they provide their own security on top of that. This is how we support that requirement, is you select private IP, and then that will route it over your private VIF if you have a direct connect. So if you don't have a direct connect, the private IP is not available. It doesn't make sense. That's the only place that the private IP will route, and that's for that particular scenario where you have a direct connect into AWS, you've configured a private VIF interface to your SDDC, but you still want to run a VPN. And that works exactly the same way as the public VPN, except your endpoint is now the private IP, and it routes traffic over your direct connect. The remote public IP, also they didn't really update that UI name when we added that private IP option, but this is what it really means, is the destination gateway. So whatever your VPN gateway is that you're connecting to, you put its IP, however we're going to reach it. So if you're using private IP, that's going to be a private IP that's reachable over your direct connect. That network, destination network, is going to have to be advertised over the direct connect. If you're using internet, then that just has to be an internet IP address, a publicly routable IP. The BGP local IP and prefix length, what this is really saying is this is the tunnel interface you want to create for BGP. We talked before about using an APIPA range, a 169.254 range. That's the easiest way to do it. You know that those addresses are not going to be routed anywhere else. We do have a couple of exclusions that we use internally for other purposes, so that we don't allow you to use those. But you know, so you don't want to use, you can't use anything between 164.254.0 and 31, and then there's a 101 to 10, couple of IP addresses, like a single, looks like a /30 and the 101 range. So you know, you can take something like 169.254.50. And what you give it here is you actually give it the IP address you want the VMC SDDC to use for its interface, and then the size of the subnet. It's a little confusing because usually you see the notation, CIDR notation is you're giving the network address, so the .0, for example. In this case, you're not giving the network address, you're actually giving the IP address you want to be used. So that would be, for example, .1 or .2, depending on what you're configuring. So if you're setting this up to connect to an AWS VPN, they will usually define the .1 or the first address in the network for their side, and you can't control that. They just look at your subnet, they figure it out, and they give you a config file that you can reverse engineer or just get the generic settings. So if you're connecting to AWS, then you're going to use the last subnet, the last IP in the subnet if you're using a /30. So for example, you give it 169.254.50.2/30, and that tells me that we're going to use 169.254.50.2 as the interface for the VPN tunnel on this side. And then you're going to put in the BGP remote IP, which is going to be the other IP, the other host IP available in that /30, which would be 169.254.50.1 in our case here that we're talking about, where we're connecting to AWS. The BGP remote ASN. So we talked about there's a local ASN and a remote ASN. We don't show you the local ASN because it's set globally for your SDDC. For all VPN connections use the same local ASN, and you can see it at the top right above the box. There's a edit local ASN number. I don't know if it'll let you click on that while you've got this open. Yeah, it does. Okay. So this shows us what our local ASN is, and you can edit it if you need to, but keep in mind that if you edit this, it will affect all your VPN connections. So if you've got existing VPNs that are working, you're adding a new one, you come here and edit this, you're going to break all your other VPNs until you go and update them on the on-prem side. So the default that we use is 65,000. This one we've updated it, so this is not a default anymore. This is 65,020. Generally, you're going to want to use a private ASN, so that's the 65,000 range. Usually, you could look up exactly what the private ASNs are. It's kind of like the RFC 1918 IPs. There's a list of private AS numbers that you could use for internal purposes. And so you'll generally take one of those unless you have a need to do a public IP and then a public ASN, and it would have to be one that you own. So virtually never would you be using a public AS number in this case. So once you set this, we'll just close this because we know what it is. And now you're going to configure your remote side, which is pointing to your on-prem AS number. So whatever you've configured on your on-prem gateway for your BGP autonomous system number, you'll put in here. And on your on-prem side, or your AWS side, whatever you're connecting to, you'll have to point to the local AS number from here. So in this case, you would set your on-prem gateway to use 65,020 as the remote remote BGP site. And that should be it. If you've got all that right, you click save and you give it a few seconds, a minute or two, and your tunnel and BGP should come up and look like the VPN connection below, where you see green up, and then you see your VPN BGP is also green. So if we click on those eyes, we'll get some additional information. So we see the channel status, and as I noted, with a route-based VPN, you see how we set up a single SA that is covering quad zero on both sides. So all traffic will be able to route over that, and we rely on the BGP routing, which is visible here, and we see our remote and our local AS numbers. So in this case, they're switched around. And if you look at that view routes like we looked at before, you'll be able to take a look at what we're actually learning and advertising. So we see that we're learning 6 routes from the remote side.
And on the advertised piece, one thing to look at is that top one, and this is just inherent knowledge. So this is my SDDC. So 1057/23 is the management CIDR that I supplied when I deployed it, and then the 172.16 is a segment. So if you want, you can click on close and then segment. So the only things that are going to be advertised, number one, so when you first deploy it, if it's a multi-node SDDC, there will be no network segments for workloads. So the only thing you'll be advertising back across your VPN or your direct connect would be your management subnet, and then anything that you create on the network segment will also automatically be advertised, with the caveat of if it's a routed network. So if you create an extended or a disconnected network, either one of those network types would not be advertised. Yep.
Very good, Vanna.
You like that?
I do.
I always try to bring some value. I appreciate that, because that's a fantastic discussion, because I know that the VPN stuff has been always a source of a lot of questions and a lot of issues in some cases with people getting onto the service, because it's kind of the second step after you set up an SDDC would be to then do this.
Yeah. Or I mean, yeah. So, a lot of customers, at least for me in particular, they want to do a direct connect, but there's just the waiting process of actually getting that set up. So from an onboarding perspective, you're right, Matt. I mean, once the SDDC is deployed, this is pretty much I would say 99+% of the time is the next logical step. It's, most of the time it's no additional cost, whereas a direct connect would be. Most customers are already going to have some type of device that they can pair to on the other side in their on-prem environment.
So now here's a question for you. So I know that when we added NSXT, we added the route-based VPN. So is under the NSXT banner now, why or would you ever pick the policy-based?
Policy-based, one thing I did want to note about policy-based is it's not actually routing. Policy is policy for a reason because it actually applies policy. And what's the difference between policy and routing? Well, good question. Routing we talked about uses BGP and it follows normal routing rules. So it's negotiating these BGP sessions and setting up subnets that are advertised on one side or the other, and that will follow typical routing rules like more specific path win. So if you have two overlapping networks, so say you're advertising 10.0/8 at one location, for example, over a direct connect, but now you have a VPN that you want to have just 10.2.2.0/24. It's within that same network, but it's a more specific one. Well, if you advertise that over a route-based VPN, it'll take that more specific network and it will understand, well, routing rules follow more specific networks, so therefore I'm going to go this way. It'll choose distances. Policy-based is actually more of a pattern match. It's applying a policy, saying if you see traffic coming out this interface that is going to this, that matches this pattern, then send it over the VPN, encrypt it, and send it out. So it doesn't follow all the same rules exactly, and that can sometimes be useful. There are a few cases where you actually don't want something to follow rules. You want the traffic that's going there to be going out somewhere that it wouldn't normally. There are very specific edge cases that this would occur, but it's still important to understand that policy is not routing. Usually, the decision is more based on what you're connecting to. So one particularity about policy-based networks is, as I noted before, is they set up an SA for every network. It's actually every network pair. So if you have, if you're advertising or you're putting in your config, I should say, 4 different networks, because you've got 4 different networks on VMC that you want to use this VPN for. 4 different network segments. You select them all. Now you've got 4, and then you put one network on your remote side, 10.0/8. Well, that's going to create 4 different tunnels. Every pair has another tunnel. And then when you connect your VPN, if you were to go to that tunnel status, you'd actually see the tunnel, the IKE, phase 1, and then you'd see 4 different SAs shown, one for each combination. Then you say what happens if you want to start advertising, say, oh, I need, in addition to 10.0/8, I need 192.168.10.1 for my, or 10.0/24 for some management stuff. Well, now you've gone and doubled, because now every tunnel has to have you have to have a tunnel between every pair. So now instead of 4 tunnels, you now have 8, and so on. And so that can quickly get out of hand, because every tunnel, every SA has a little bit of overhead, right? It's got a bit of memory overhead. It's got to keep track of these sessions, because every SA is a complete phase 2 negotiation. There's a new key that's determined for each SA. And so you can get a lot of different tunnels, and you can end up with weird situations that may not be ideal. And this is part of why we normally would prefer a route-based VPN, because you don't have to worry about all those SAs. There's always only a single SA, and you route everything over that. So it just, some endpoints only support policy-based VPNs. That's just the way it works. It's a pretty common type of VPN. A lot of people, when you think IPsec VPN, they think of policy-based VPNs. That's all that they know. Route-based is something different. And the other thing, as I mentioned before, is some people don't support BGP. So we need BGP in order to do our route-based VPNs. Not every device will support BGP, or not every administrator wants to run BGP in their environment. In that case, they're back to being limited to a policy-based VPN. So our recommendation is route-based if you can, but there are sometimes incompatibility or other considerations that would override that and say, well, I can support a policy-based. It's a simple connection. I've got only 2 subnet pairs. I've got 10.0/8 on one side, and one network on the other side. It's only one tunnel pair. That's fine. Everything else is the same. So you could use it either. It just depends really on what you're connecting to.
Oh yeah, that makes sense. And like I said, I mean, in the old It's kind of funny to say old world, but a year ago that was the only option we had for customers was the policy based. Now, maybe for some edification, because that's my word of the month. Actually, that's a word of the month last month. I'll have to update that. Now, connecting to Amazon's transit gateway. You guys want to discuss a little bit of some of the intricacies there with setting up the VPNs to that?
So I did mention a couple of points about connecting to Amazon VPN. The transit gateway to Amazon, our connectivity path to it is through VPN. So it's a standard Amazon VPN. You set up a customer gateway, and then you set up a VGW, and the difference is that you link that to a transit gateway. So you create all these configurations. When you go to your transit gateway, you would create a VPN endpoint. Because there are currently two types of endpoints you can create on a transit gateway. There's a VPC or a VPN. When you create a VPN, it links it to a VGW VPN gateway, and then you have to create the VGW and the customer gateway to match your site. So customer gateway is defining basically just the IP address, I think, of the of your VMC SDDC. So you would go through that config, and you're definitely going to want to use a route-based VPN for connecting to TGW, and that's because AWS really only supports route-based VPN. Now, they say they support policy-based VPN, but what they're really doing is taking advantage of a special case situation where, it's kind of like a stuck clock is right twice a day, right? When you use a route-based VPN with a policy-based VPN, under certain circumstances, they'll work together, even though one side is talking route-based VPN and the other side is talking policy-based VPN. And that's because of the way I told you that a policy-based VPN sets up an SA for every network subnet pair, and a route-based VPN sets up one SA for everything. Well, what happens is, obviously one side is greater than the other. So if you have a single tunnel, a single pair of subnets on your policy-based VPN, and you tell the other side it's a route-based VPN, you could end up making it work because you get the policy-based VPN sends only what it needs to. The other side sends kind of everything, but it knows the routing. It can use a static route to figure out that it only is actually sending what it needs to. And so it works. But where it stops working is if you need more than one network, because now your policy-based VPN is going to try and set up a second SA, but your route-based VPN only knows how to do one SA. So AWS does indicate that there's a limitation of only having a single subnet pair when you're using a policy-based VPN solution. So that's a big limitation. We've had a couple of customers who have run into that, where you started off, everything's good, you've only got one subnet, and then they realize, oh, we need to add another subnet, and now you're stuck because you add it and it just doesn't work. And sometimes one works, sometimes the other one works, because it all depends on which tunnel comes up first from the policy VPN point of view. So either one will work, but it just depends which one it is. So it really creates an awkward situation. So route-based, definitely the way to go. And you just follow AWS's regular VPN settings. The trick is usually you set up your VPN gateway, and then you download the generic config file. And you're going to have to search through, but if you search through, you'll find all the configuration terms that line up with the options that we went through today, the different ciphers, the phase one, the BGP IPs, the ASA numbers, all the parameters that you need. The public IPs, the endpoint IPs, they're all there in the generic config file. You just kind of have to look through, and sometimes the naming is worded slightly different. Like I said, phase one is IKE or ISACAMP. Phase two is SA or tunnel. So there's sometimes different terminology that's used, but when you know those basics, you're usually able to, they're usually fairly evident, and you can line up the configuration options and get your tunnel to come up, and then you have a VPN connection to TGW.
So easy.
Well, one little thing too is that the default for TGW is to use ECMP. ECMP is something we didn't talk about. We don't currently support that in VMC. It's on our roadmap. But what happens is when you set up a TGW, it always sets up two tunnels. So it gives you two different IP endpoints. how you would implement that is you would actually set up 2 separate tunnels in your VMC. You'd create 2 different route-based VPNs, and you'd follow the config. So AWS and that generic config will show you each one separately, and you'd create 2 separate tunnels. They should both come up, but what happens is both of them will advertise the same routes. And with ECMP, basically what it does is it says that if you have 2 routes that are exactly the same cost and everything, it will load balance traffic across them. So it'll learn both routes, put them both in the forwarding table, and you'll be able to use both channels. It'll sort of use an algorithm to determine which flow goes into which tunnel, whether it's like a round robin or usually it's some sort of IP hash, IP header based solution. So it'll look at the IP parameters and of each packet and decide which tunnel it maps to. We don't support ECMP, so what happens is we see 2 different routes and we're only going to take one of them. Only one of them will make it to the forwarding table. So it will generally choose the first one, and that will go into the forwarding table, and so only one tunnel will actually be active. But you set up both of them because they could fail over. So if one goes down or one switches over, that's fine. It just switches over to the other one. They both work. We are looking at supporting ECMP to allow that those 2 tunnels to load balance. But right now they operate in active standby. But it still means it's a good idea to set up both tunnels so that you have a little bit of redundancy. That's what AWS is expecting.
That's excellent advice. Thank you, Michael. It was a very good topic, seeing as we didn't come in with one. Thank you for jumping in there and educating us. And like I said, it's a very, very common thing that we go through. And Z touched upon the other part where, the other good part of our customers come in via direct connect, which maybe we'll do a different session on. But
searching. I don't see anything to connect. Check the device you'd like to use and make sure Bluetooth is turned on. To set up a new device,
I really don't know what my Alexa's thinking I said, but apparently I don't have a device to connect to.
You tell Alexa to set up your VPN?
Yeah, actually, you know what? They probably could do that. But yeah, so those are obviously the 2 ways to get into to VMC is the direct connect to the VPN. Now there is technically, I guess, a third option, and that's just opening this up to the internet. But I don't think we actually have anybody that does that.
I have I think I have the one corner case customer that is using VMC as a complete island.
Okay.
At least to my knowledge. So yes, that also has a use case, but it's I think it's a pretty corner use case.
Yeah, and I mean it is an option out there because there are people that use kind of AWS in that regard, right? So you can actually just open up in the settings here. You can change it from private to public, and essentially that means you just get to your vCenter webpage over the internet and can get in and do everything you want to, and all of the VM traffic would route out through the internet as well, depending on where it was going. But yeah, it seems to be kind of a corner case at this point. But it's a viable option if you just want something in the cloud. And, especially,
yeah,
sorry, go ahead.
I guess another example of that is I've got a customer. It's not quite entirely isolated, but similar, where they're essentially just using the layer 2 extension for VM connectivity, but everything else from a management perspective is isolated and as an island.
Yeah, and that's a good option as well. Like I said, so there is a myriad of options for depending on however we want to connect to this thing, and we try to support all. And as Michael said, we're continuing to add support for other features, and it's come a long way from where we were a year ago. I would say with what we had for connectivity options with the NSXV. So as with everything, it's all going the right way. I didn't have anything else. I don't know if there's any questions out there. I've been kind of monitoring the Twitch chat and stuff, and there hasn't been any so far. So I think we could probably call her around 10 minutes early. I do really appreciate Michael, you jumping in and kind of doing a good overview of the VPN technologies and what they all mean. I know a lot of people could probably fight their way through the setup, but may not understand everything that they're actually doing when they do that. So I think that was a great education piece, and I appreciate that, and thanks Z as well for adding context and loaning your SDDZ SDDZ for our Canadian and European friends, to kind of demo with. We didn't break anything, so everything should be fine.
I'm not a networking guy, but I did stay in a Holiday Inn Express last night.
Yeah, that's good. All right, so I think tonight our time, tomorrow EMEA time will be another EMEA office hours. I know Will and I have hammered out the audio issues that he had last week, so in case you made that last week and noticed that Will was talking to himself for an hour, which I removed that video, although I should have probably saved it first just for entertainment purposes, but that's all resolved, so tonight should be good. I think there's going to be a few people on. I don't know if Aiden's going to make that tomorrow, but I know that Persona and Will are definitely on the docket. And then we have the APJ session on Thursday for office hours. And next week we're going to be doing another webinar. Topic to be decided. If anybody has any suggestions or any ideas for what they'd like to present, I have been talking to some of our VCPP brethren that joined us today to maybe go over some of the partner program stuff. I don't know if we'll quite get that ready for next week, but that's definitely going to be coming so that people can get a good example of what our partner community does around this, because it's not just VMware that does this. Our partners do heavily participate in this, and a lot of them have quite a few customers that they do the managed service offering for. So I'd like to kind of discuss that as well, so that the customers know that they have options. It's not just VMware. We can do it. We can help you. We can do it for you. But there's a lot of partners out there as well that may either be more local or have other features such as faction that we don't have in the product quite yet. That brings value. So with that, I think I'll call it a stream. And I thank everybody for tuning in, for watching this on YouTube, and I look forward to seeing you guys next week. Thanks.